There are two ingredients in most kitchens right now that, combined in the right ratio, outperform every glass cleaner on the market. They leave no streaks, no residue, no film. They don't require a surfactant, a dye, or a fragrance. They cost, combined, essentially nothing, because you almost certainly already own both of them. The glass cleaner industry in the United States generates over $3 billion a year in retail sales. Most of what fills those bottles is water. The rest is something you can replicate in under 2 minutes. Stick with me. What you're looking at when you see a streak on a cleaned mirror is not dirt. It's not grease. It is residue left behind by the cleaning product itself. A thin, invisible film of surfactant that didn't evaporate because surfactants don't evaporate. You spray, you wipe, and the surfactant remains on the glass. Light hits the surface at a low angle, and you see the evidence of the thing that was supposed to remove evidence. To understand why this happens, you need to understand what glass is at the surface level. Glass is non-porous. It doesn't absorb liquids. When you apply a solution to it, everything in that solution stays on the surface until it either evaporates or is physically wiped away. Water evaporates cleanly, leaving nothing behind. Surfactants, the compounds in cleaning products that lift oils and grease, do not evaporate. They dry on the surface as a molecular film. Under ordinary room lighting, that film is invisible. In direct light, at certain angles, it becomes the streak you bought the product to prevent. Now zoom further in. At the microscopic scale, a glass surface is not flat. It's a landscape of peaks and valleys, irregularities too small to see but large enough to trap material. Mineral deposits from tap water, calcium and magnesium ions, settle into those valleys when water evaporates, building the white haze typically called hard water film. Surfactant residue from repeated cleaning layers on top of that mineral base. With each cleaning cycle using a standard glass cleaner, you are not removing this accumulation. You are cleaning the top surface of it and leaving the foundation completely undisturbed. What dissolves alkaline mineral deposits on contact is an acid, a mild one, specifically acetic acid, which is what white distilled vinegar is. Acetic acid has a pH of roughly 2.4 to 3.4 depending on concentration. That range is sufficient to break the molecular bonds holding calcium carbonate and magnesium carbonate together, the precise compounds that form water spots, hard water film, and the white haze that builds on shower glass over weeks of use. The mineral deposits dissolve into the solution. You wipe acetic acid, diluted with water to the correct ratio, evaporates from a glass surface completely. No film, no residue, no layer left behind to catch the light. The streak does not form. Applied chemistry literature and food science research confirm that dilute acetic acid effectively dissolves calcium and magnesium carbonate scale at concentrations as low as 5%. The natural acetic acid concentration of standard white distilled vinegar sold at any grocery store. This is the same descaling chemistry used in industrial food processing equipment, commercial kitchen descaling, and coffee machine maintenance. The concentration required is not exotic and the material is not specialty. It is a basic chemical property of a weak acid applied to an alkaline mineral deposit. The result: complete dissolution, complete evaporation, zero residue. Does not belong to any brand. It belongs to the chemistry. The bottle that contains it costs under $2. The list of surfaces this addresses covers almost every piece of glass in a standard home. Windows accumulate a mineral film from rain and condensation. Shower enclosures build hard water scale with each daily use, the heaviest accumulation in most homes and typically the first place people give up and accept permanent cloudiness. Bathroom mirrors collect soap mist and airborne water. Chrome fixtures cloud over with the same calcium and magnesium deposits. Oven door glass fogs with combined grease and mineral residue. Car windshields develop an interior haze from dashboard plastics outgassing onto the glass. Skylights, glass front cabinet doors, sliding glass doors, greenhouse panels. The mechanism is identical on all of them. A single bottle of white distilled vinegar handles the entire list through the same underlying chemistry. Now consider what is actually in the glass cleaner you have been buying. A standard product in this category contains roughly 90% water, between 4 and 8% isopropyl or ethyl alcohol to accelerate evaporation, a small percentage of surfactant for fingerprint and grease removal, a chelating agent included because the manufacturer uses tap water in production, a blue or teal dye, and a fragrance compound. The dye does no cleaning. The fragrance does no cleaning. The chelating agent compensates for the manufacturer's production water quality, not yours. The surfactant, as already established, leaves behind the film that produces the streaks the product claims to eliminate. The formula causes the problem it is sold to solve. Here's the question nobody in the glass cleaning industry wants you to ask. If acetic acid effectively dissolves every mineral deposit that currently accumulates on glass, and if it does so without leaving anything behind, why does a category generating over $3 billion a year in retail sales not mention it? Not in fine print, not on the back panel, not in the ingredient list. The chemistry is documented in food science literature and used industrially. It does not appear on the cleaning shelf. You already know the answer. A $2 solution that permanently handles the problem a household is paying $30 to $60 a year to manage is not a business. It's a business ending. The glass cleaning market depends on products that require continued repurchase. A solution you mix in 30 seconds, that lasts a year, that costs almost nothing to replicate, does not generate a subscription. There is no next quarter's revenue in a bottle of vinegar and water. A household buying glass cleaning products at between $30 and $60 annually has spent between $300 and $600 over a full decade. The acetic acid solution costs under $5 for the same period, assuming a full bottle of white vinegar per year, which significantly overestimates actual consumption. That is not a price difference. That is the difference between a necessary purchase and an unnecessary one. Here is exactly how to make it and what to do with it. Combine equal parts white distilled vinegar and distilled water in a clean spray bottle. The 50-50 ratio is the standard starting point, sufficient acidity for routine mineral film, fingerprints, and soap residue, dilute enough to be safe on coated glass surfaces, frames, and adjacent materials. For heavier hard water scale on shower glass or exterior windows with significant buildup, increase to 2 parts vinegar to 1 part water. Add 1 teaspoon of isopropyl alcohol per cup if faster drying is needed. Always use distilled water, not tap water. Tap reintroduces the calcium and magnesium you are removing. For application, use a microfiber cloth, not paper towel. Paper towel leaves lint on glass at the microscopic level that becomes visible at certain angles. Microfiber lifts dissolved residue away completely. Apply top to bottom on vertical surfaces or in circular motions on mirrors and windows. Avoid applying in direct sunlight on exterior glass. The solution evaporates before the dissolved deposits can be wiped away. One honest limitation: the vinegar smell is present during application and dissipates within a few minutes. In an enclosed space, a minute or two of ventilation handles it. There is no lingering odor once the glass is dry. This solution descales and removes surface residue. It is not a disinfectant and does not sanitize surfaces. A batch in a standard 32-ounce spray bottle has a shelf life of months to a year. Acetic acid does not degrade at room temperature in a sealed container. You make it once. You use it until it's gone. You spend under $2 to replace it. Here is the part that stays with me. Acetic acid has been used as a cleaning and descaling agent since at least ancient Rome. Records of vinegar applied to mineral deposits on surfaces predate the industrial chemistry industry by more than 2,000 years. The compound in a bottle of white distilled vinegar on a grocery store shelf today is chemically identical to what people were using across civilizations with no advertising budgets and no quarterly revenue targets. It worked then. It works now. The chemistry has not changed. Only the packaging around it has. If this gave you something useful today, share it with someone who has been buying glass cleaner on autopilot for years without questioning why. They deserve to know the recipe costs almost nothing. This channel digs that knowledge back up. Subscribe if that matters to you.